Here's a quick little acronym to help you remember how X-ray is created. SCADE, source, confinement, acceleration, deacceleration, and then energy conversion. So step 1, source. I've zoomed in here on our cathode, and you can see that we have both a large filament and a small filament. Remember that the large filament is better at heat dissipation, should be used for tube warm-up and large techniques, and the small filament is going to be better at spatial resolution. Step 2 is going to be confinement. Surrounding the two tungsten filaments is going to be a nickel focusing cup. Why nickel? Because it's negative, and the electrons being produced by those filaments are also negative, so it therefore confines them into a more narrow electron space cloud. Step 3, acceleration. So when we select the KVP, we are selecting the potential difference between the positive anode and the negative cathode. As we select a higher KVP, we're going to have a higher acceleration across that tube gap. Also, can I just take a second to say how cool it is that somehow we were able to cut a hole through the metal housing of an X-ray tube and expose the glass envelope inside without breaking it? Step 4 is deacceleration. Remember the law of conservation of energy. Energy is not created nor destroyed, it can only transfer forms. So as our electrons are traveling across the tube gap at an insanely high energy, they're going to slam into our positive anode, and therefore all of that energy needs to go somewhere, and that takes us to step 5. Step 5 is energy conversion. So here we have just an anode pull out, which is pretty cool because you can actually see the pitting of the anode in different areas where too much heat has been applied at the same spot without proper heat dissipation. Anyways, at the anode, we're going to have either Bremsstrahlung radiation or characteristic radiation occurring, depending on the KVP selected. I'll explain more of those in part 2 later this week. Stay tuned.